see that this is the example that we are going to solve. By observation, you might feel that this is a huge truss. In this, I can tell you the number of members are 13. So to take each joint and solve it is going to be time consuming. But by observation, special case is going to help us in this case a lot. What happens? I'll just show you. This is a very, very simple question. Rather than going step by step, that is the stability criteria and finding out the support reactions, I would first prefer finding out the zero force members. You will feel that it is a very simple case then. Now, come to joint B over here. If you look at joint B, the force in member AB and BC are collinear, and we have seen that the special case wherein if there are two forces collinear and the third force passing from that joint will be a zero force member. So force in member BF will be a zero force member. So I have made the force in member BF as a zero force member. Now, come to joint F. If you look at joint F, the force in member AF and FG are collinear. At joint F, I'm having two force members, that is BF and CF. But just now I have said that BF is a zero force member. So I can say that it is not there. So I can clearly say that force in member FC will be a zero force member. Okay, now move on to joint C. What happens at joint C? Again the same case. Force in member BC and force in member CD are collinear, and I'm having two forces coming out of from joint C, that is CF and CG. But right now we have just declared that CF is a zero force member, right? So CG will be again a zero force member. Now come to joint G. I guess you might have got the knack of solving this type of a question now. If I come at joint G, I can directly say that the force in member GD will be a zero force member. Now, should I move on to joint D and say that the force in member DH will be a zero force member? Think again. No. The reason for that is I have one more external force, that is the 24 kilonewton force acting at joint D. So that is not possible. I cannot say that force in member DH is zero because I have this 24 kilonewton force acting at joint D. Yes, I can apply the second special case wherein these two force members are collinear, CD and DE are collinear. Yes, I can apply that case and say that force in member DH will be same as the external applied force of 24 kilonewtons. Since the 24 kilonewton force is acting towards joint D, then DH will be a compressive force acting towards the joint and the magnitude will be 24 kilonewtons. Now, this is how we have calculated these zero force members. What about the similar force members like AB and BC? Now, just in case, if I find out the force in member AB, we have said that AB will be same as BC. So, if I find out the force in member AB, I'm getting the force in member BC. If I've got the force in member BC, at the same time I'm getting force in member CD as well. Correct? Now, what about DE? Can I say that? Yes, because the special case 2 is applicable over here and CD will be same as DE. What about this side? If I find out the force in member AF, don't you think I'm getting the values for FG and GH? Yes, I'm getting the values for FG and GH as well. Now, the only force member that is left out is EH. So I just need to solve for that joint, that is E joint. So basically, by observation, I have found forces in most of the members. All I need to do is I need to solve for two joints, joint A and joint H. Don't you think that is a simple case now? Or rather, a simple example. Now, this is a routine for us to find out the stability criteria. N equals 2j minus r. I know the number of members are 13. You can just cross check. Number of joints, I'll just count that for you. 1, 2, 3, 4, 5, 6, 7 and 8. So if I solve it, I'll get this as a perfect truss. Now, the next step that we do in this is find out the support reactions. Support reactions at A and at H. At A, I'm having a hinge support, and at H, I'm having a roller support. Two support reactions for hinge and one support reaction for roller. So the total number of reactions will be 3. What I'm doing is I'm first finding out the support reaction. So I'm taking the moment in that case. I have one vertical reaction over here, say VA, and a horizontal reaction, say HA, and one vertical reaction at H, I'll call it as VH. Now when I'm taking moment about A, the reaction forces are going to have a zero effect in moment. Now, what about this force and this force? They are going to create a clockwise moment. So that will be a negative sign for me. So minus 24 into 15 and minus 40 into 21. What about this vertical reaction over here, the VH reaction? That is going to create an anti-clockwise moment. So a positive sign for that. So that would be VH into 15. Since I'm getting the value as positive, I can say that VH is coming out as 80 kilonewtons. And the assumption that I have done of the vertical reaction at H acting upwards is correct. Now what I'll do is I'll substitute value of VH in this equation to find out the vertical reaction at A. So I'm getting the vertical reaction at A as 16 kilonewtons with a negative sign. That means my assumption of VA acting upwards is wrong. So I have to change that and say that VA will be acting downwards. Now in this whole truss, I can see that there is no horizontal force. So the horizontal reaction at A will be 0. Okay, so now this is how we have calculated the support reactions. Now I'll move on to the next step, that is finding out the forces in each member by method of joints. The first thing that we do will be finding out the forces by observation. By observation, when I look at B, force in member BF is 0 and AB and BC will be same. After having taken joint B, I move on to joint F. If I move on to joint F, I know BF is 0. I have concluded that CF was also 0. So I can just write that CF is 0 and force in member AF and FG will be same. Now when I move on to joint C, CF was 0. I can say that CG is also 0. Then BC and CD will be same. The force in member BC and force in member CD will be same. If I move on to joint G now, I know CG is 0. I can say that GD is 0 and force in member FG and force in member GH will be same. I have done joint B, then joint F, then joint C, and then joint G. Just to cross check, B, F, C, and G. Now I'll move on to joint D. What happens if I move on to joint D? This is a zero force member. So practically at joint D, I have only 4 forces acting. The 24 kilonewton force, the force in member DH, force in member CD, and force in member DE. So I have already said that force in member DH will be 24 kilonewton compressive. Now what I'll be doing is I'll move on to joint A, find out the forces in members AB and AF. Once I get that, I can say that AB equal to BC, BC equal to CD, CD equal to DE, and AF equal to FG and FG equal to GH. So in that way, I have calculated forces in almost all the members except one, that is EH. So I'll take joint E at the end. Now the horizontal reaction at A was 0. The vertical reaction at A is 16 kilonewtons, which is acting downwards. We have already seen the calculation for that, and that is over here. VA 16 kilonewton acting downwards. So that is what I have done. I have shown at joint A 16 kilonewton force acting downwards. Now what I need to do is I need to find out the angle alpha over here. So what happens in this case? I know this length, that is 8 meters, and this complete length to be 15 meters. So I can apply the tan ratio over here and find out the angle alpha. I've got the angle as 28.07 degrees. So now I just need to apply condition of equilibrium and find out force in member AF and in AB. So I can say that force in member AF is equal to Fg and Fg is equal to Gh, that is 34 kilonewtons. And all the forces will be compressive. Now, I'll apply the condition of equilibrium in the horizontal direction. So, the forces in the horizontal direction will be FAB and the force FAF. So when I solve the force for member AB, I'm getting the value as 30 kilonewtons tensile. I can directly say that the force in member AB equal to BC, BC equal to CD, and CD equal to DE, that is 30 kilonewtons. Now, I have already calculated the forces in members AF, FG, GH, AB, BC, CD and DE. I have got the value in DH by observation as 24 kilonewtons. The only force in member, that is EH, is left out. So for that, what I'll do is I'll take joint E and solve it. Now in this case, I need to find out the angle theta. To find out angle theta, again I can use the tan ratio. I know the opposite side as well as the adjacent side. I got the angle as 53.13 degrees. So I'm getting the value for EH as 50 kilonewtons compressive. All I need to do now is tabulate the results. Now I know that force in member AB, BC, CD and DE is same, that is 30 kilonewtons tensile. AF, FG, GH is 34 kilonewtons compressive. EH I just calculated and that was 50 kilonewton compressive. Now what is left out in this? BF, FC, CG and GD. Those are zero force members. So I'll combine it and write as zero force members. BF, CF, so this is how I can solve any given example of truss by using method of joints. In the next lecture, we will see how to solve any truss by using method of sections. Thank you.